viewers of Araatech, today we are talking about a very important topic. This is a platform which is called Hugging Face. It provides NLP models for those who know how to use them, and they use it and they make a lot of money as a freelancer, as a professional of IT. So let's talk about that. Hugging Face. Hugging Face can be defined as an artificial intelligence research organization and platform that provides a diverse range of natural language processing models, tools, and resources for researchers, developers, and the wider artificial intelligence community. Its website is huggingface.co. To gain an overview of the platform, understand its main components, including the model hub, transformers, library, datasets, tokenizers, and more. Model Hub overview. The Model Hub is a central repository within Hugging Face that hosts a diverse collection of pre-trained models across various natural language processing tasks. These tasks range from text classification and language translation to sentiment analysis and more. Functionality. Users can browse and access pre-trained models, making it a valuable resource for researchers and developers. The hub supports the sharing and fine-tuning of models, fostering collaboration within the community. Transformers Library overview. The Transformers Library is a powerful open source library developed by Hugging Face. It provides a comprehensive set of tools and pre-trained models based on transformer architectures, which have demonstrated exceptional performance in NLP tasks. Functionality. Researchers and practitioners can leverage the Transformers library to easily incorporate state-of-the-art models into their projects. The library supports popular models like BERT, GPT, Roberta, and more, making it a go-to resource for working with advanced NLP architectures. Datasets overview. Hugging Face's datasets component offers a curated collection of datasets commonly used in NLP research and applications. These datasets cover a wide range of topics, facilitating experimentation and training of models on diverse data sources. Functionality. Users can explore, download, and utilize datasets directly within the platform. This streamlines the data preparation process, making it convenient for researchers and developers to access high-quality datasets for their projects. Tokenizers overview. Tokenization is a crucial step in processing text data for NLP models. Hugging Face provides efficient tokenization tools and libraries, allowing users to prepare their data for consumption by transformer-based models. Functionality. The platform's tokenizers are designed to handle various tokenization tasks, ensuring compatibility with transformer architectures. Users can integrate these tools into their workflows to pre-process text data effectively. Community and collaboration overview. Hugging Face fosters a vibrant community of artificial intelligence enthusiasts, researchers, and practitioners. The platform encourages collaboration, knowledge sharing, and contributions to open source projects. Functionality. Users can engage with the community through forums, discussions, and collaborative projects. This collaborative spirit promotes the exchange of ideas, expertise, and the continuous improvement of tools and resources within the Hugging Face ecosystem. In summary, the Hugging Face platform serves as a comprehensive hub for accessing, sharing, and collaborating on cutting-edge resources in the field of NLP and AI. Whether you are looking for pre-trained models, libraries, datasets, tokenization tools, or a supportive community, Hugging Face provides a unified environment for researchers and developers to advance their work in natural language understanding and processing. Transformers Library. Delve into the Transformers Library, a significant contribution by Hugging Face. Learn about transformer architectures like BERT, GPT, and Roberta, and discover how pre-trained models are utilized for various NLP tasks. Transformers Library and Transformer Architectures. Transformers Library Overview. Significance. Hugging Face's Transformers Library is a pivotal contribution that simplifies the usage of transformer-based models in NLP. It offers a unified interface, making it easier for researchers and developers to work with these advanced architectures. Transformer Architectures. BERT. Bidirectional encoder representations from transformers. Overview. BERT is a transformer architecture that excels in capturing bidirectional contextual information. It considers the entire context of a word in a sentence, making it particularly effective for understanding relationships between words. Utilization. Pre-trained BERT models are applied to various tasks, including text classification, named entity recognition, question answering, and sentiment analysis. Its bidirectional nature allows it to grasp nuanced meanings in language. GPT, Generative Pre-trained Transformer. Overview. GPT is a transformer architecture designed for generative tasks. It is trained to predict the next word in a sequence, enabling it to generate coherent and contextually relevant text. Utilization. GPT models find applications in tasks such as language modeling, text completion, and creative text generation. They showcase proficiency in generating human-like responses. Roberta, robustly optimized BERT approach. Overview. Roberta is an optimization of the BERT architecture. It removes the sentence order, prediction task, and employs dynamic masking during training, resulting in improved performance. Utilization. Roberta is commonly used in various NLP tasks such as sentiment analysis, text classification, and language understanding. Its robustness makes it suitable for a broad range of applications. Utilizing pre-trained models, transfer learning paradigm concept. The Transformers library follows a transfer learning paradigm. Pre-trained models are initially trained on large corpora to learn general language representations. Fine-tuning. These pre-trained models can then be fine-tuned on specific downstream tasks with smaller task-specific datasets. This allows models to adapt their knowledge to more specialized applications. Task-specific applications. Flexibility. The versatility of pre-trained transformer models allows their application in a multitude of NLP tasks, whether it's sentiment analysis, text summarization, named entity recognition, or machine translation. These models can be fine-tuned for specific use cases. Customization and extensions. Flexibility. The Transformers library provides flexibility for customization and extension. Researchers and developers can modify and extend these models to cater to specific domains or tasks, adapting them for unique requirements. Community contributions, collaboration. The success of the Transformers library is amplified by the collaborative efforts of a vibrant community. Users can benefit from community contributed models, tokenizers, and utilities, fostering an environment of shared knowledge and advancements. In summary, the Transformers library by Hugging Face is a powerful tool that facilitates the use of transformer architectures like BERT, GPT, and Roberta in NLP tasks. Its unified interface, coupled with the versatility of pre-trained models, allows for efficient development and deployment of state-of-the-art solutions in natural language understanding and processing. Model Hub. Explore the Model Hub, a repository where researchers and developers share pre-trained models. Understand how to access and fine-tune models for specific applications. Introduction to the Model Hub. Purpose. The Model Hub is a central repository hosted by Hugging Face where a diverse array of pre-trained models is shared. These models cover a wide range of natural language processing tasks and are contributed by researchers and developers from the global community. Accessing the Model Hub. Web interface. Users can access the Model Hub through the Hugging Face website huggingface.co/models. The web interface provides an intuitive platform for exploring available models. Transformers library integration. The Model Hub is seamlessly integrated with the Transformers library, making it easy for users to access models directly within their Python code. Exploring available model. Diverse collection. The Model Hub hosts models based on various architectures including transformers like BERT, GPT, Roberta, and more. Users can explore models suitable for their specific tasks and requirements. Filtering and search. The web interface allows users to filter models based on architecture, task, or language. The search functionality assists in finding models that align with specific criteria. Model pages, detailed information. Each model has a dedicated page providing detailed information such as the model's architecture, training data, hyperparameters, and the tasks it excels in. This information helps users make informed decisions. Usage examples. Model pages often include usage examples and code snippets, enabling users to quickly integrate models into their projects. Accessing pre-trained models. Download models. Users can download pre-trained models directly from the Model Hub. The Transformers library simplifies the process, allowing for easy integration into Python projects. Hugging Face CLI. The Hugging Face command line interface CLI provides additional flexibility for interacting with the Model Hub. Users can use the CLI to download models, manage their local cache, and contribute their models. Fine-tuning for specific applications. Transfer learning paradigm. Fine-tuning involves taking a pre-trained model and adapting it to a specific task or domain. This leverages the knowledge encoded in the pre-trained model and tailors it for more specialized applications. Custom datasets. Users can fine-tune models using their own datasets, allowing for customization based on specific requirements. Fine-tuning is particularly valuable when dealing with domain-specific language or tasks. Hugging Face Transformers library integration. Seamless integration. The integration between the Model Hub and the Transformers library ensures a seamless workflow. Users can directly load models into their Python scripts using the library, making it convenient for experimentation and development. Community collaboration. Contributions. The Model Hub is a collaborative platform where researchers and developers contribute their models. The collaborative spirit fosters the sharing of knowledge and advancements within the NLP community. In summary, the Model Hub is a pivotal component of the Hugging Face ecosystem, offering a centralized repository for pre-trained models. Researchers and developers can explore, access, and fine-tune these models for specific applications, thereby leveraging the collective expertise of the global NLP community to enhance their own projects. Tokenization tools overview. Importance of tokenization. Context. Tokenization is a fundamental pre-processing step in natural language processing that involves breaking down text into smaller units called tokens. Tokens can be words, subwords, or characters. depending on the tokenization strategy. Hugging Face Tokenizers Library. Introduction. Hugging Face provides a dedicated library for tokenization aptly named tokenizers. This library offers efficient and flexible tools for handling tokenization tasks in NLP workflows. Open source nature. The tokenizers library is open source, allowing users to inspect the implementation details and even contribute to its development. Key features. Efficiency. Hugging Face tokenization tools are designed for efficiency, ensuring that the tokenization process does not become a bottleneck in the overall NLP workflow. Compatibility. The tools are compatible with various transformer architectures, making them suitable for a wide range of pre-trained models hosted on Hugging Face. Usage in the Transformers library. Integration. The tokenizers library is seamlessly integrated into the Hugging Face Transformers library, creating a unified environment for working with transformer-based models. Consistency. This integration ensures consistency between tokenization tools and models, simplifying the user experience and making it easy to pre-process text data for model input. Tokenization strategies. Word level. Users can tokenize text at the word level where each word becomes a token. This is common for traditional NLP tasks. Subword level. Subword tokenization allows for breaking down words into smaller units, capturing morphological variations and improving the handling of out of vocabulary words. Character level. Tokenizing at the character level is another strategy useful for tasks where individual characters are meaningful, such as text generation. Customization options. Social tokens. Users can easily add special tokens to the vocabulary such as CLS or SCP, which are commonly used in transformer-based models for tasks like classification and sequence tagging. Padding and truncation. The tokenization tools provide options for handling padding and truncation of sequences, ensuring consistent input shapes for models. Handling multiple sequences. Pair encoding. For tasks involving pairs of sequences, that is, question answering, the tokenization tools support pair encoding to handle multiple input sequences efficiently. Token IDs and attention masks. Token IDs. The tokenizers library assigns unique IDs to each token in the vocabulary, facilitating the mapping of text to numerical representations. Attention masks. Attention masks can be generated to inform the model which parts of the input sequence to attend to and which to ignore. Community and documentation support. Hugging Face's tokenization tools are well supported by the community, and users can find comprehensive documentation and examples for effective usage. In summary, Hugging Face's tokenization tools provide a versatile and efficient solution for pre-processing text data in the context of transformer-based models. Their integration with the Transformers library ensures a seamless experience, making it easier for researchers and developers to prepare text data for training, fine-tuning, or inference. Datasets Library Overview. Introduction to the Datasets Library. Purpose. The Datasets Library by Hugging Face serves as a centralized repository for a wide range of datasets used in natural language processing, research, and applications. Key features. Curated datasets. The library provides access to a curated collection of datasets, ensuring quality and relevance for various NLP tasks. Ease of use. Datasets are pre-processed and made easily accessible, reducing the burden of data preparation for researchers and developers. Accessing the datasets library. Web interface. Users can access the datasets library through the Hugging Face website. huggingface.co/datasets. The web interface allows for browsing and exploration of available datasets. Integration with Transformers library. The datasets library is seamlessly integrated with the Hugging Face Transformers library, facilitating a unified experience for users. Exploring available datasets. Diverse collection. The library hosts datasets covering a wide spectrum of NLP tasks, including but not limited to text classification, named entity recognition, sentiment analysis, machine translation, and more. Filtering and search. Users can filter datasets based on criteria such as task, language, and domain. The search functionality assists in finding datasets relevant to specific research or application needs. Dataset pages. Detailed information. Each dataset has a dedicated page providing detailed information about its structure, format, and the tasks it is commonly used for. Usage examples. Dataset pages often include usage examples and code snippets, helping users understand how to load and utilize the datasets effectively. Accessing datasets. Python API. The datasets library provides a Python API for easy programmatic access to datasets. Users can leverage the API to seamlessly integrate datasets into their NLP workflows. Transformers library integration. Like the Transformers library, the datasets library is integrated into the Hugging Face ecosystem, allowing users to work with datasets directly within their Python scripts. Handling splits and versions. Splits. Datasets may have predefined splits for training, validation, and testing. Users can easily access these splits based on their specific needs. Versions. The library supports versioning, allowing users to access specific versions of datasets for reproducibility and consistency. Community contributions. Collaborative platform. The datasets library is a collaborative platform where researchers and developers can contribute their datasets, fostering the sharing of diverse data sources, utilizing datasets for different tasks. Training models. Researchers and developers can use datasets for training machine learning models, whether they are pre-trained language models or task-specific models. Evaluation and benchmarking. Datasets facilitate the evaluation and benchmarking of model by providing standardized and diverse test sets. Experimentation. Users can experiment with different datasets to analyze model performance across varied domains and tasks. In summary, the datasets library by Hugging Face is a valuable resource for researchers and developers in the NLP community. Its curated and easily accessible datasets, coupled with integration into the Hugging Face ecosystem, streamline the process of data acquisition and preparation for a wide range of NLP tasks. Pipeline API overview. Introduction to the Pipeline API. Purpose. The Pipeline API by Hugging Face is a high-level interface that allows users to easily apply pre-trained models to perform specific NLP tasks without the need for extensive coding. Key features. Abstraction of complexity. The Pipeline API abstracts away the complexity of loading and using pre-trained models, making it accessible for users with varying levels of expertise in machine learning. Task-specific pipelines. The API provides task-specific pipelines for common NLP tasks, enabling users to seamlessly integrate models into their workflows. Supported tasks. Text generation. The Pipeline API supports text generation tasks, allowing users to generate coherent and contextually relevant text using pre-trained language models. Sentiment analysis. Users can perform sentiment analysis on text data, determining the sentiment positive, negative, neutral expressed in a given piece of text. Translation. The API facilitates language translation tasks, making it easy to translate text between different languages using pre-trained translation models. User-friendly interface. Simple invocation. Users can invoke the pipeline API with just a few lines of code. The simplicity of the interface is designed to lower the entry barrier for users who want to quickly apply NLP models. No model loading required. The API handles the loading of pre-trained models in the background, eliminating the need for users to manage model weights and configurations manually. Customization options. Model selection. Users can specify the desired model for a particular task, allowing for flexibility and customization based on performance or task specific requirements. Task configurations. Some tasks may have additional configurations, and users can customize these configurations based on their preferences. Efficiency and speed. Batch processing. The API is designed for efficient batch processing, enabling users to process multiple inputs simultaneously for improved speed and performance. Community and documentation. Supportive community. The pipeline API is supported by the Hugging Face community, providing assistance and sharing knowledge through forums and discussions. Documentation. Comprehensive documentation is available, guiding users on how to use the pipeline API effectively for different NLP tasks. In summary, the Pipeline API by Hugging Face is a user-friendly interface that empowers users to leverage pre-trained models for common NLP tasks with minimal effort. Its simplicity, task-specific pipelines, and customization options make it a valuable tool for quickly incorporating advanced NLP capabilities into diverse applications. Hugging Face community engagement, forums and discussion platforms. Hugging Face Forum. The Hugging Face Forum is a dedicated platform where developers, researchers, and enthusiasts gather to discuss various topics related to NLP, machine learning, and Hugging Faces, tools and libraries. Stack Overflow. Users often post questions related to Hugging Face tools and libraries on platforms like Stack Overflow, where the community actively participates in discussions and provides solutions. Participating in discussions, ask questions. Users can ask questions about specific challenges, seek guidance on using Hugging Face tools, or request help with code related issues. Share insights. Experienced users can share their insights, tips, and best practices, contributing to the overall knowledge base of the community. Discuss latest developments. Discussions often cover the latest developments in NLP, advancements in Hugging Face models, and emerging trends in the field. Contributing to open source. GitHub repositories. Hugging Faces projects, including transformers and datasets, are hosted on GitHub. Users can actively contribute to the development of these projects by submitting bug reports, suggesting enhancements, or even submitting code contributions. Collaborative coding. Collaborative coding efforts on GitHub allows community members to work together on improving existing functionalities or adding new features to Hugging Face's tools. Knowledge sharing, tutorials and guides. Users often share tutorials and guides on using Hugging Face tools for specific tasks. These resources help newcomers get started and provide insights into advanced usage. Sharing projects. Developers frequently share their projects and applications built with Hugging Face tools, showcasing real-world applications and inspiring others. Utilizing Hugging Face documentation, access the official documentation website. Visit the official Hugging Face website at huggingface.co/documentation section. Explore the documentation section on the website to access comprehensive guides and information. Browse documentation sections. Transformers library. Start by exploring the documentation for the Transformers library, which is a key component for working with pre-trained models in NLP. Understand the library's functionalities, classes, and methods. Datasets library. If you are interested in working with curated datasets, check out the documentation for the datasets library. Learn how to access, load, and pre-process datasets for your NLP tasks. Tokenizers library. Delve into the documentation for the tokenizers library to understand how text data is pre-processed and tokenized before being fed into models. Pipeline API. Explore the documentation for the Pipeline API to understand how to use pre-trained models for specific NLP tasks with a simple and intuitive interface. Tutorials and getting started guides. Getting started guides. Look for getting started guides or tutorials that provide step-by-step instructions on setting up your development environment, installing libraries, and running basic examples. Task-specific tutorials. Explore task-specific tutorials that guide you through common NLP tasks such as text generation, sentiment analysis, and language translation using Hugging Face's tools. API reference. Transformers API reference. Dive into the API reference sections for the Transformers library. This section provides detailed information about classes, methods, and parameters, helping you understand the library's capabilities. Datasets API reference. Similarly, explore the API reference for the datasets library to understand the available functionalities for working with datasets. Tokenizers API reference. For the tokenizers library, refer to the API reference to gain insights into the tokenization process and how to customize it for your needs. Example code and Jupyter notebooks. Explore code examples. Look for example code snippets throughout the documentation. These examples can serve as templates for your own projects. Jupyter's notebooks. Check if there are Jupyter notebooks available that provide interactive examples and demonstrations of specific tasks using Hugging Face's tools. GitHub repositories. GitHub repositories. Visit the GitHub repositories associated with Hugging Face's projects such as Transformers, datasets, and tokenizers. GitHub often contains additional examples, issues, and discussions that can be valuable for learning. Stay updated with changelogs. Stay informed about the latest updates and changes by checking the changelogs for each library. This ensures that you are aware of new features, improvements, and bug fixes. Community and support. Community forums. The documentation may provide links to community forums. Engage with the community, ask questions, and share your experiences. Support channels. If you encounter issues or have specific questions, explore the support channels mentioned in the documentation, such as community forums or Stack Overflow. In summary, thoroughly exploring the official documentation, tutorials, and guides provided by Hugging Face is a crucial step in mastering the platform's tools and libraries. By following the documentation, you can gain a deep understanding of the functionalities, best practices, and advanced features offered by Hugging Face's ecosystem for natural language processing. GitHub repositories. Transformers repository. Visit the official Transformers repository on GitHub. github.com huggingface/transformers. This repository is central to working with pre-trained models in NLP. Datasets repository. Explore the datasets repository github.com/huggingface/datasets. This repository focuses on created datasets for NLP. Tokenizers repository. Check out the tokenizers repository github.com huggingface/tokenizers. This repository deals with efficient tokenization of text data. Get familiar with the code base. Read documentation. Start by reading the README files and documentation available in the repositories. Understand the project structure, features, and how to set up the development environment. Explore source code. Dive into the source code to understand the implementation details. Identify key components, classes, and functions that are relevant to your interests or the areas you want to contribute to. Issues and discussions. GitHub issues. Explore the list of issues in the repository. This is a good way to find tasks that need attention, bug fixes, or new features to be implemented. Discussions tab. Check the Discussions tab on GitHub. This is where broader conversations happen, and you may find discussions related to ongoing development, future plans, or community initiatives. Contribute code. Fork the repository. Fork the repository to create your own copy. This allows you to work on changes without directly affecting the main code base. Create a branch. Create a new branch for your changes. This helps keep your contributions isolated and organized. Make changes. Implement the changes or additions you want to contribute. Follow the coding conventions and guidelines specified in the repository. Tests. If you are adding new features or fixing bugs, make sure to include tests to ensure the stability of the code base. Submit a pull request. Once your changes are ready, submit a pull request to the main repository. Provide a clear description of your changes and be open to feedback from maintainers and the community. Review and collaborate. Code reviews. Participate in code reviews for your own pull requests and others. This is a valuable learning experience and it ensures that quality of contributions. Collaborate with maintainers. Engage with project maintainers and other contributors. Discuss design decisions, address feedback, and work collaboratively and improving the code base. Stay updated. Watch the repository. Watch the repository to stay updated on new issues, pull requests, and discussions. This helps you stay informed about ongoing developments. Follow change logs. Keep an eye on the change logs to understand the evaluation of the code base and to be aware of new features and improvements. Community interaction. Join discussions. Actively participate in discussions both on GitHub and potentially on community forums. Share your experiences, ask questions, and contribute to broader conversations. Community guidelines. Adhere to the community guidelines and code of conduct to ensure a positive and inclusive environment for collaboration. Recognition and learning. Recognize contributions. Hugging Face often recognizes contributors. Your contributions, regardless of size, are valuable, and recognition can come in the form of mentions, badges, or other acknowledgements. Learn from others. Learn from the code written by experienced contributors. Understanding their approaches can enhance your coding skills and knowledge. In summary, contributing to Hugging Face's GitHub repositories provides a practical and collaborative learning experience. It allows you to actively engage with the open source community, improve your coding skills, and contribute to projects that have a significant impact on the field of natural language processing.